Determine the values of x for which the geometric series converges, then find the sum of the series for these values of x in terms of x. We have the sum from n equals 1 to infinity of the nth power of -7 times the nth power of x. Recall when we have an infinite geometric series, we can write the formula for a sub n in the form of a times r to the power of n, where r is the common ratio, and if the absolute value of r is less than 1, the series converges, and it converges to a, the first term, divided by the quantity 1 minus r. If the absolute value of r is greater than or equal to 1, then the series diverges. Going back to the given series, because both -7 and x are raised to the nth power, let's rewrite a sub n as the nth power of -7x, which gives us the sum from n equals 1 to infinity of the nth power of -7x. In this form, it's easier to identify r. Notice r is equal to -7x. And now to determine which x values for which the geometric series converges, we need to solve the absolute value inequality, the absolute value of -7x less than 1. Recall, to solve this type of inequality, we need to set up and solve two inequalities connected by the word and. We need to solve -7x less than 1 and -7x greater than -1. Notice for the second inequality, we reverse the inequality and also change the sign on the right. And now solving the inequality on the left, we divide both sides by -7. Recall when solving an inequality, if we multiply or divide by a negative, we also must reverse the inequality. Simplifying, the solution is x not less than but greater than -1/7. And for the second inequality, again, we divide both sides by -7. Simplifying, again, we reverse the inequality. We have x less than +1/7. So this is the interval for which the infinite geometric series converges. Let's go ahead and graph this on the number line. Let's go ahead and plot -1/7 and +1/7. Notice because of the inequalities, -1/7 and +1/7 are not in the interval. We make open points on both values. And now we're looking for the values where x is greater than -1/7 and less than 1/7, which should be all the values between -1/7 and +1/7. We now know the series converges for x on the open interval. Using interval notation, we have an open parenthesis, -1/7, comma, 1/7, close parenthesis. And now to determine the sum of the series for these x values, we need to determine the quotient of the first term divided by 1 minus r. Well, notice the first term, a sub 1, is equal to the first power of -7x, or just simply -7x. And we know the common ratio is -7x, which indicates the infinite sum is equal to the first term, a sub 1, of -7x divided by the quotient 1 minus r, which is 1 minus -7x. Simplifying, we have the infinite sum is equal to -7x divided by the quantity 1 plus 7x. Again, this would be the infinite sum only when x is on the open interval from -1/7 to 1/7. So we'll say on this interval, the infinite sum is equal to -7x divided by the quantity 1 plus 7x. I hope you found this helpful.